Hello YouTube, this is Cheska from STEM APKs. Welcome to another tutorial. In this tutorial, we're going to continue where we left off in the last tutorial. As you remember, in the last tutorial, we worked with the color analysis. In this tutorial, I'm really excited because we're going to take everything that we've learned so far, and we're going to apply it to some applications in molecular biology, biotechnology, um, like gel electrophoresis and Western blot, cell counter, microscopy analysis, and so on. So it'll be cool. Just in case you're not familiar with it, you'll learn something for those people that are in that field that they might learn something when it comes to OpenCV. So let's get started. The first thing we're going to do is create a drop down like we always do. We're going to create this directory, the scientific directory. We're going to create these two files inside this directory. And I already did them. I already put them here. Sorry, wrong file. And it's this file right here, not to get you confused. I created this file, scientific file, which is this file right here. This file, scientific, OCR, OCR, and inside the OCR I created OCR analysis TSX and then the page TSX. And these files are the ones that I'm right here. So you're going to remember that I'm going to put this in my GitHub so you can copy and paste it. So you take it, copy it, and go into the program and go into OCR analysis TSX and paste it. And it's this file right here. And you do the same for page TSX, which is this file right here. So you can see it is this file right here. So you do the same, put it in here and paste it. Let me save this one. If you're getting an error, it's because you might not have this installed. Make sure you install this one. Don't install the Tesseract by itself because I don't think it's been. I had some problems in installing it, so I recommend that you do this one instead. It's Tesseract, and just use this command right here, npm install Tesseract.js, and it should work. So let's talk about this code because there's a lot going on, and we're going to be using Tesseract for most of these files in this dropdown. So the first thing we do is, like always, we bring the hooks from React. We use some of the files that we've been using, threshold controls, image upload from other files that we've been using. We're going to be creating selection the rectangles again, so we need to do the mouse down, mouse functionality to create the rectangle as we transparent rectangle. So this is what we're doing here. Here we're checking to make sure OpenCV is loaded, making sure the state, the hooks from that we've been using, and the mouse functionality to create the dragging, click and drag. Here we create the parameters for the threshold and the resize factor because it's going to have the ability to dynamically change the thresholds and dynamically change the resize factor. And also it's going to have a boolean of it's going to ask you want to use the O2 algorithm, yes or no. So it's basically just a click. Here, these are the references to the DOM element. Here are the constant controls for the sliders. These are the initial sizes, like we've done a lot before. This code here handles the image upload to make sure it creates a temporary canvas and it makes sure that both images are the same size, width, and height. We've done that before. This is nothing new. We've done it in every tutorial so far. Here we start talking about the canvas as we create the X and the Y for the mouse, and it's the mouse event to the DOM element. That's what that is drawing here. Here we're drawing, creating a temporary canvas where we're going to be drawing the overlay. So as you can see here, it's getting the context, and here you create the rectangle, the X and the Y. It's a rectangle, and like we did in the other one, it's going to be transparent because the way we do it is using the alpha channel of a 0.1, so it's just barely, so you can see where you're going as you're drawing the rectangle between the start position and the end position. And more of the same here. That's all about the rectangle and the click and drag. And here starts validating to make sure that these CV is loaded, make sure that you're ready for it. And then this starts the OpenCV magic. So here we're doing, uh, when you select the rectangle, it has to have a minimum of a 10 by 10. And if you don't do a 10 by 10, it's going to complain and say to you that the area is too small. It's creating the temporary canvas, like I mentioned earlier, and it's creating two, because one of them is going to have the source data here, and the other one is going to be an empty matrix where you're going to put the process. So this is what is happening here. Here is just the resize factor logic from the resize factor to make it smaller or bigger. You're converting to grayscale. We always do RGBA because there's 3 channels plus the alpha channel, so it's going to grayscale. Equalize histogram to make sure that to make better contrast. Apply thresholding. We've been doing that all along. So it's going to give you a choice to choose the Boolean between OTSU or the thresh binary, which is the adaptive threshold. And if you don't choose one, it's going to go right into this one. It's going to show the process image. Here is very important here because this is where you let Tesseract know what characters you're dealing with. So here I'm dealing with the Latin alphabet. So I'm dealing with uppercase and lowercase and character and numbers. We're using a mode of 6. This can be changed. If you want to mess with this, you can. This is everything here can be uh, you know done for your own application that you're using. Here we're cleaning up, and here's all rendering, and I'm going to show you that right now what it looks like. This is all UI rendering. We create this page, and now if we go here and we open scientific imaging, it should be here. And if we go here, it's a color histogram. Why is complaining? The string for a class function to get object. Page DSX. Obviously, I did something wrong there. So let's. Oh, I never saved it. That's why. Now it works. So now when it gives you the option, actually, I double it up here. So all you need to do is if you want to change anything, just find it wherever it is. And in this case, it should be right here. So I have it double, as you can see. So I'm just going to comment this out. And now if I save it, it should go away. So now it's going to give you the option to choose a file. In this case, I'm going to choose a file. Let's say, let's go with OCR. Let's go with, I want to show you something. Let's do a logo first, so you know it works with a logo like this. So you upload the logo, you choose the area that you want to apply OCR on it. You go into process selection, it chooses and it creates and it tells you the extracted text. If you want to use OTSU, process, process selection, and it's dynamically changed. So it's awesome. So as you can see, it changes whether you want to do it or you know, like you. Uh, in this one, I didn't select an area, and that's why I complain. You process it, and it's nice and clear. So you can apply the threshold. It changes the threshold, as you can see. Make it because it's using all those other algorithms like equalize histogram, and they do a pretty good job. So if you want to go back to using OTSU, you can. So this is what is happening here. But I wanted to show you something else here because let's say that you want to do, let's say that you want to work with the Latin alphabet. In the Latin alphabet, of course, we're using English alphabet, so it's using the same alphabet. So we do the selection that we want, choose it, and it does pretty good. No, no surprises there. But let's say that you're working, being that this is scientific imaging, you're going to be working with equations, or you're going to be working with Greek letters. For example, an equation like this. If you try to do this with the Latin alphabet, it's got the delta and the lambdas, but let's say that you go into process selection, it fails miserably, right? Because these are Greek letters. It picks up the Latin letters, but it doesn't pick the Greek letters. So if you have something like this, all you need to do is go into the file, OCR analysis, and you can change it here. You can, instead of English, and you can add Greek to it. And I didn't do it on this one, so let me go into my other code here and go into OCR analysis because I did it here, but I forgot to copy and paste it. Command C. And now if I go to OCR analysis, and then I go put it here, and let's comment this one out. And now let's uncomment these ones, and I'll show you what is going on here. All I'm doing, did I do the right one? I think I copy and pasted the same thing again. Let me go here again. Yeah, I got the wrong one. Sorry, guys. So, Command C. And going to OCR analysis. Yeah, I did the same one again. And then Command B. And now these ones not only has the Latin alphabet and the numbers, but it also has the Greek alphabet, uppercase and lowercase. So you got the lowercase and you have the uppercase. And that's all you need to do. So now, if we comment that one out and then just use this one, save it, and now we go back to where we were before, and then we select it again, we refresh the page to make sure that the changes were applied. Go back here, and then if we do the same again, hopefully it works, and there it goes. Now you get the Greek letters. And just like that, you can do not only with the English Greek alphabet, any alphabet that is compatible, of course, with Tesseract. But you can do here numbers. You can do all kinds of stuff. This is just the tip of the iceberg. I'm just showing you this because everybody's going to have a different application, and this can come very handy when you're dealing with certain applications. But so this is one thing that I wanted to show you, and also let me go here back here. This tutorial is getting a little bit long already, so I'm going to wait until the next one because I don't want to. This is very important because we're going to be using gel electrophoresis also for Western blot and for two Western blots and the count. So I want to take my time. So I'm going to end this tutorial here. This is the end of this tutorial. If you like this tutorial, please click the like box, subscribe to my channel, and I will see you next time with another tutorial. Take care.